Hello everyone, welcome to another video. Here we are going to see the Archimedean spiral. It is defined as the Archimedean spiral is the locus corresponding to the locations over time of a point moving away from a fixed point with a constant speed along a straight line that rotates with a constant angular velocity. That is, here I am going to consider a line AB having a finite distance and a red colored point or body which is moving from B to A with a constant linear velocity. So we can say here that the body is having a straight line motion with constant velocity. Now at this same time, when the body is moving from B to A, what if the straight line path AB itself is rotating about the fixed point B as a center with a constant angular velocity? Then the body will be moving in a different path, and the path of motion is called the Archimedean spiral. In short, we can say the Archimedean spiral is a combination of the linear motion and angular motion. Here, the body from point B reaches the point A after moving around it once. This is called the Archimedean spiral with one convolution. When the body reaches from B to A after moving it around 1.5 times, then it will be called Archimedean spiral of 1.5 convolutions. And if the body reaches from B to A after moving around it twice, then it will be called Archimedean spiral of 2 convolutions. And also, always it is not necessary that any point on this straight line path should be the center of rotation. That is, here the path AB is rotating about the fixed point O. Then the spiral will be different, and here also it can be of 1, 1.5 and 2 convolutions. In this video, I am going to show you how to draw the Archimedean spiral with 1, 1.5 and 2 convolutions. This is Arjun, and let's make it simple. Here we have a question, that is, a point moves away from a fixed point O and reaches a distance of 50 mm while moving around it once. Its movement from O being uniform, draw the curve traced out by the point, and also draw tangent and normal at any point on the curve. That is, here we have a fixed point O, and the body, or otherwise point itself, is moving from point O to a distance of 50 mm while moving around it once. So we can definitely say that this is an Archimedean spiral with one convolution. First step is, here we have to draw a circle of 50 mm radius. Then we have to divide this particular circle into 12 equal parts. So we know that dividing a circle into 12 equal parts gives us an angle of 30 degrees. Now next step is to divide the straight line between the center point O and 12 here into 12 equal parts. For that we have to use usual method, that is, from the point O we have to draw a straight line with an angle, with an included angle of 30 degree, and the length of this particular line here should be any value which should be divisible by 12. Here the radius or the distance between the point O and 12 is 50 mm. So we have to choose any value near to the 50 mm distance which should be exactly divisible by 12. 60 mm is near to the 50 and also divisible by 12. So I am going to take 60 mm distance with an angle of 30 degree. Next we have to draw a straight line connecting the end point of this particular line here with the end point of O12, that is the point 12 here. So now we can divide this 60 mm straight line drawn here into 12 equal parts. we can divide 60 by 12, that is 5 mm. So it should be like this. Now I have divided this particular inclined straight line here into 12 equal parts. Then we have to draw parallel lines parallel to this particular line here through each and every individual division points on this line. So here the line O12 is divided into 12 equal parts. Now it is required to mark the points on the divisions like this. Now the next step is we have to measure the distance between point O and 1 dash here. This is 4.167. With that particular distance we have to draw an arc connecting the point O on the line O1. Now we have to measure the distance between O and 2 dash. Here it is 8.33. With that particular distance we have to draw an arc with the center O on the line O2 here. Like this. Then we have to measure the distance between the point O and 3 dash. This is 12.5. With that particular distance we have to draw an arc with center O on the line O3 here. Then repeat the same procedure for remaining points on this straight line. Like now finally we can draw a curve starting from the point O through each and every intersection of arc and the straight line here. So this is how we can draw the Archimedean spiral with one convolution. Now we have to draw the tangent and normal at any point on the curve. So for that I am going to mark any point on the Archimedean spiral. Let's say this is the required point P on the intersection of this line and curve. So at this particular point I am going to draw the tangent and normal. For that, first step is to draw a straight line connecting the point P here and O. Then next we have to calculate a constant value which is constant for a specific spiral. Here we have the formula constant K equal to R minus C by theta, where R is the radius of the larger circle here and C is the radius of the smaller circle if there is any. Here there is no small circle, so we can take the C value 0 and theta equal to the angle of turn, which is here 360 degree or 2 pi, because it is making one convolution. So theta value should be in radians, that is equal to 2 pi. So R minus C by theta equal to 50 minus 0 by 2 pi, that is equal to 7.96 mm, which is approximately 8 mm. So here we have to draw a straight line connecting the center point O with the distance of 7.96 or 8 mm approximately, with an included angle between the line OP of 90 degree. Let's say this particular point here is Q. Now for getting the normal, we have to connect the point Q and P here. This is the required normal, and for getting the tangent we have to draw a line 90 degree to this particular normal here. So this is how we can draw the tangent and normal to the Archimedean spiral. Let's move on to the next question. Here, construct an Archimedean spiral of 1.5 convolutions given the greatest radius 60 mm and the shortest radius 10 mm. So here we have two circles of 60 mm radius and 10 mm radius. So now we have to draw the Archimedean spiral of 1.5 convolutions. This is the particular question. Like I have told you before, it is an Archimedean spiral like this. First step is to draw two different circles of 60 mm and 10 mm radius concentric to each other like this. Now second step is to divide the circle into 12 equal parts. So this step is common for any kind of Archimedean spiral. Here you can see there are 18 parts on the circles. It is actually divided into 12 parts, but after the 12th part it is marked as 13, 14, 15, 16, 17, 18 again on the points 1, 2, 3, 4, 5, 6 here. That's because this question is to draw the Archimedean spiral of 1.5 convolutions. So one convolution means, or one turn means 360 degree of angle. Here 1.5 turns means 360 plus another half, that is 180, that is 540 degree of turn. In one turn it should be 12 equal parts. So in half turn it should be 6 equal parts. Then 1.5 turn means 12 plus 6, that is 18 parts. So that's why here I have marked 18 parts. So now we have to divide the straight line. Straight line means the line between two circles here. This is the required straight line corresponding to the straight line AB here. So we have to divide the straight line into 18 equal parts. So for dividing this particular straight line into 18 equal parts, we can use the usual method. That is, let's say I am going to draw a line starting from this particular point here with an angle, with an included angle of 30 degree with any measurement, with any distance which is divisible by 18. Previously we have taken a straight line which is divisible by 12. Here we should have to take a distance which is divisible by 18. Here let's say I am going to take 90 mm. 90 mm is exactly divisible by 18. So I am going to take 90 mm with a 30 degree of included angle like this. Next, as usual, it is required to join the end points of this particular line and the point 12 like this. Now it is required to divide this inclined straight line into 18 equal parts. 90 divided by 18 gives 5 mm. With a gap of 5 mm we can divide it into 18 equal parts. Now this inclined straight line is divided into 18 equal parts. Then we have to draw lines parallel to this particular line here through each and every division points on the inclined straight line. Now we can mark the points on the divisions of horizontal straight line here like this. So here it is divided into 18 equal parts. So likewise, if it is asked to draw the Archimedean spiral of two convolutions, the straight line should be divided into 24 equal parts, because one convolution means 12 equal parts, then two convolution means 24 equal parts. That you have to note. So now the next step is to measure the distance between the point O and 1 dash here. Here the distance is 12.778. So with that particular distance of 12.778, we have to draw an arc with the center O on the first straight line here, O1. Now we have to measure the distance between O and 2 dash. This procedure is the same like in the previous one, that is 15.556 here. With that particular distance of 15.556 mm, we have to draw an arc with the center O on the straight line O2 here. Now repeat the same procedure for the remaining points on the straight line here. Here the 12th point lies on the same 12 dash point here, so it is not needed to take the arc at this point. So after that, then we will get a figure like this. Next we have to draw the curve starting the point here at this particular point. It should not be drawn from the point O. So this is how we can draw the Archimedean spiral with 1.5 convolutions. How to draw the tangent and normal for this curve? For that, it is required to calculate the k value, that is constant value, that is k is equal to r minus c by theta. Here r is equal to 60 mm, which is the larger circle radius, and c is equal to 10 mm, which is the smaller circle radius, and theta is 1.5 convolutions, that means 540 degree or otherwise 3 pi radians. So we will get k is equal to 60 minus 10 by 3 pi, that is equal to 5.30 mm. So first step is to specify the point for drawing tangent and normal. Let's say I am going to draw the tangent at this intersection point. So first step for drawing the tangent and normal is to draw a straight line starting from the point P to the point O here. Then we have to draw a line perpendicular to OP with a distance of k value, that is here we have the k value of 5.305 mm. Next step is to connect this particular point here with the point P. This line is the required normal, and if we draw a line perpendicular to normal through the point P, we will get the required tangent. So this is how we can draw the required tangent and normal for 1.5 convolutions. So likewise we have a different Archimedean spiral. For example, here in this figure, this is the first one, that is the Archimedean spiral with one convolution, and here the same thing, same Archimedean spiral with one circle and 1.5 convolution. Here you can see the curve is starting from the center point of the circle, and also then we have the 1.5 convolution Archimedean spiral with two circles here. Then this is the Archimedean spiral with two convolutions. Here you can see the line is divided into 24 equal parts. So this is how we can draw the Archimedean spiral. Thank you very much for watching, and let's catch up in another video.